Okay, so I wanted to do a quick screencast on calculations of error, both as it's done in the book and as we'd like you to do them in class this year. First of all, you usually see actual values given a value. Like if you're in science, you're given a value and you're given an uncertainty, like 100 plus or minus 1, or 3.3 plus or minus 0.2. Your textbook makes a fair deal about calculating percentage, and percentage is just equal to the uncertainty divided by the actual value times 100. So for the first one, if it's 100 plus or minus 1, that would be 1 over 100 times 100, which is obviously 1%. For the second one, it would be 0.2 divided by 3.3 times 100, which I'll go ahead and use a calculator for. 0.2 divided by 3.3, which is about 6%. What I'm more concerned with is that you're able to present values, derived values, in the form of x plus or minus z, given initial values like 100 plus or minus 1 and 3.3 plus or minus 2. So let's say I want you to find uncertainty in velocity, given those values for distance and time. So the way you approach it is to think of which values are going to give you the biggest possible velocity and which will give you the smallest possible velocity. So in this case, if it's 100 plus or minus 1, you get the biggest velocity with the distance actually being larger, so 101 meters, and the time being smaller, which is 3.1 seconds, because distance is, velocity is distance divided by time. So that's going to be equal to 101 divided by 3.1, and my calculators disappear. I should have minimized it, not closed it. So 101 divided by 3.1 is 32.58. So we'll call it 32.6 meters per second. The smallest velocity is with 99 meters and 3.5 seconds. And so that's going to give us 99 divided by 3.5, which is 28.3. So it equals 28.3 meters per second. So we know that our velocity is going to be somewhere in the range 28.3 and 32.6 meters per second. So what we want to find is we want to find the middle value, and to express these as the extremes. So the middle value is going to be the average of those two. So we take our 28.3 plus our 32.6 divided by 2. That's 30.45. And if we want to know how far it is from one end to the other, we just subtract either end. So in this case, minus 28.3, 2.15. Remember, it was 30.45. So the average value is going to be the center, which in this case is 30.45. And then the uncertainty is going to be the distance from the center, which is going to be 22.15. Now, we want to round up because we always want to overestimate uncertainty rather than underestimate it, so we would say 30.5 plus or minus 2.2 meters per second. That's the limits that we would give on what we know about the value of uncertainty. And so you want to be able to use this kind of approach throughout the year.